All right. Hi, good afternoon. All right, we're gonna get started. It's nice to see a lot of friends catching up. Welcome everyone, and thank you for joining us for this event. It is really a big pleasure to introduce tonight's guest, Volkan Alkanoglu. Volkan is one of those people that have and continue to have like 20 lives in architecture. He has been the source of very meaningful contributions to the architectural practices of others. When he was younger and starting a career in practice, he authored many projects that you would know, but you might not know that he's responsible for them. He has taught in the faculties of SciArc, Georgia Tech, and the GSD, influencing many generations of students that are now out there practicing in the world. He works full-time on an adjacent design field, and most likely you have unsuspectedly worn or are wearing an original Alkanoglu. And he is the founding principal of VA Design, which is the focus of tonight's talk. As an architect and artist based in Portland, Oregon, but with projects really everywhere, the work of VA Design focuses on the pursuit of novel form through spatial, material, and technological explorations. The mission of VA Design centers, and I quote, on reappropriating paradigms of design typology through creative interventions. VA seeks to inspire a discourse of how the public domain is occupied by forming opportunities for social inhabitation. Part of this mission is to investigate and transform the built environment through the implementation of innovative techniques, new methods of making, and sustainable systems. Volkan's portfolio of projects range from a timber and steel pedestrian bridge that opened last year in Fort Worth, Texas, to a large-scale public art in Pleasant Hill in Phoenix. Every week one hears about a new shortlist he is part of, or a new competition he has won, or a new award that has been granted. Recent ones include public art projects for Indiana, Oregon, Texas, California, Colorado, and Washington D.C. I think that's just the last few months, with a Responsible Disruptor Award by Metropolis magazine in March of last year. As you walk through campuses, cultural venues, and corporate headquarters around the country, you might come across his work, both site-fitting and site-changing. Volkan's projects leverage design and fabrication tools that advance the ways in which we design, fabricate, assemble, and install various kinds of structures. And one could argue that the process of doing that constitutes at heart a very classical project in architecture, a project of tectonics. From Vitruvius's Firmness, Utility, and Delight through Gottfried Semper's tectonic discourse to Mario Carpo's digital turn in architecture, the evolution of tectonic discourse in the context of computation, the questions that connect materials, tools, form, function, beauty, and affects are indeed questions about tectonics, and in the case of Volkan's work, transformed and amplified by the context of computational tools. In his work, all of those questions around functionality and organization, the rational side of tectonics, and delight and affects, the experiential side of tectonics, come together to also reveal an all-alluring aesthetic project. Please join me in welcoming tonight Volkan Alkanoglu.
Well, thank you so much, Mariana. It's very kind. I wish you can keep on talking. That was really good to hear. Yeah, my name is Volkan Alkanoglu. My pronouns are he, him. Thank you so much for having me, and thanks for coming tonight. It's also good to see so many familiar faces in the audience. So I'm quite happy to see some folks I haven't seen for quite a bit. So thanks for joining. Let's see. Yeah, I mean, as Maria mentioned, there is, quite a bit of work that, I'm trying to be part of. And if you want to break it down, it goes into products. It's about design, architecture, arts. I'm also, when it comes to product, I'm also the head of the digital creation studio at Nike Innovation, where we basically have a group of 30 plus computation designers, engineers, and are looking kind of to create the future of sports for both apparel and footwear products. I'm not going to talk about that body of work. I'm going to focus more on my personal studio. which is really engaged in design work, public art, and partially architecture. You might see some things. But really, the interest here is to engage in the production of culture, to kind of look into languages, how we can basically start to communicate between each other, how we can start to create engagement, how we can start to get folks to come together, how we can create spaces that kind of support and empower communication. And the work itself is classified into what I call signature projects and then series projects for families. When it comes to signature, these are like one-offs, things that maybe were conceptualized and live in the world. And some of them have merit to kind of then grow and scale into further ideas. And you see this, in some of the works that I'll be sharing, where it becomes more a family of ideas and concepts that just have enough kind of opportunities to be scaled into a broader context. Yeah, so the interests I have, which is, again, the production of culture, really, I'm trying to do this through my exploration of form, formation, which is then powered by technology. Sounds a bit like an advertisement here. But that's really the key of it. My interest in form is basically something that I have nurtured over many, many years since I graduated from school, and have tried to really implement this in my work. At the same time, when it comes to formation, it's more about assemblages of components, of items. It's about organizational systems, other top-down or bottom-up systems that I'm trying to implement into the work. And obviously, with the development in technology, we have now the opportunity to really use those tools to really enhance the work that we're part of and try to really create something that's quite unique, novel, and innovative as well. So when it comes to form, I'm really interested in kind of very simple forms in the beginning, and then start to charge them with information or with parameters. This could be anything really from scale, height, dimension, material, methods of make, color, and really trying to transform, initial ideas into something that then has a bit of more purpose, more performance, and really starts to adapt into its context as well. Here's just a quick kind of iteration of things that you can look at. I've been doing this for several projects in the past. This is actually one of the first ones when I stepped out of kind of corporate offices and start my own practice. This was a competition for Asuka, and Asuka is a small pavilion that's kind of put together during the Sukkot festivities in the Jewish culture. There's many rules that you have to obey when it comes to a sukkah. And these are things that I started implementing in this kind of form making, from initial ideas to the final product. This is the competition board. I think there was about 500 entries. 10 projects were selected. They were invited then to actually physically build these sukkahs, and then exhibit them during a weekend at Union Square in New York. My friend Armando is here, who back in the day helped me drive this thing from LA. This is where we fabricated it. Drive it across the country in a truck, and then basically put it on Union Square. This was quite an operation. They even published at the end a documentary about this. And what I didn't know, because this all happened, of course, in the background, the jury was quite argumentative about this particular design. There was Paul Goldberger, Ron Arad, and then your very own Tom Main, who I didn't know was quite fond of the design. And I have a quick video that shows them arguing for this thing.
This represents complete new thinking having to do with the singularity of structure, shape, scale. It's a complete different kind of approach to where architecture is going today in terms of materiality and the technology of architecture.
Yeah, so if Tom says it's good, I take it. I think Ron Arad was trying to get it off the table and he kept it on there, so I'm really quite thankful for him stepping up. So we had the chance to build this, exhibit this. This is Union Square Park in New York. You see all the other structures there. Mayor Bloomer came out at some time and selected the winner, which wasn't us, but we were quite pleased how everything turned out. This is completely made out of bamboo and rattan, so it's really kosher material that you find. And it's also fully engineered, so we had an engineer actually work on these things as well, which is not easy to ask them to design basically a rattan pavilion. And then we also opened this up to the public, and you see here, kids playing, enjoying, being part of this. And again, this is the kind of architecture that I hope to kind of create and to kind of promote, that restarts this participation of the public to engage with the work, either physically or visually. And then this project also has an afterlife. It was basically purchased by the Jehovah Museum in New York and is now in their permanent collection as the example what a sukkah looks like. So if you ever have a chance to go visit, this is what the future people will see in the future what a sukkah is supposed to look like. So going from form to formation, again, as I mentioned, I'm very interested in connecting the dots in organization systems to kind of put together things that can create a new kind of assemblage, hence maybe create novel structures, unique structures and innovative structures. This, of course, is an image generated with Midjourney, and you can maybe also start counting how many images of Midjourney I'll show tonight, but it's basically a fairing kit, which is part of motorcycles or cars, right? So you see these very dynamic shapes and forms. And interestingly enough, about 10 years ago, I did a competition for the so-called Museum of Comic and Cartoon Arts. I see Julia Kerner is in the audience here. She was actually on the jury, so thanks for picking this one, right? But this is interesting because pre-Midjourney, and if you know Midjourney and these AI tools, they're very powerful collage tools, right? They're really powerful at putting things together as a collage, kind of. This is put together in the same way. I basically didn't have access to any 3D software at the time because my computer was broken. Only had access to like Photoshop, Illustrator. So this is all basically collaged together in 2D, kind of a pre-AI or pre-Midjourney way of doing things. And again, it's about taking individual components, putting them together and creating basically something emergent from this assemblage. And this continues in the current work I'm doing, where really many parts and components come together, forming kind of new landscapes, new kind of visuals, creating different types of aesthetics and perceptions. This is a project I did at Durango in Colorado. And the images are so abstract that when I submitted this to an RFQ, which is request for qualification, this is how you apply for work. Sometimes you have to submit images as built work. I was rejected because the organizers claimed that these are renderings and not photographs, simply because of the abstraction that they're creating through their assemblage. Some other projects, again, I talked earlier about series of families. These are all in the kind of same conceptual framework where you have these extruded pixels and the assemblage of these, the aggregation of these create this kind of new landscape and new formations. Each piece is unique. Each piece is its own shape and form, has its own identity. But when they come together, they create this really new kind of configuration of geometries. And I'm just going through a couple of projects here because you can look at it from the kind of individual side, but also this is a triptych of 3 works together within a building in Baltimore, where they basically start to also communicate to each other. There's other projects that are more freestanding. This is a sculpture in Iowa, again, where we move away from the geometry of the surface, extruding pixels from a surface to more of a volumetric form. Or a project I was recently installed last week in Seattle. So the artist there, the landscape still has to go in now. But again, the idea of formation, I think you see here the potential it creates to kind of put these things together. And then currently we have a project under construction in Taiwan. This is one of those, again, a very similar kind of way of putting it together in terms of components, but the overall kind of assembly creates this very kind of unique, novel perception. And when I say powered by technology, you know, it's a very broad term, but if you look at the innovation cycles that we've been through as humanity within the last couple of 100 years, this is basically these are the main innovations that we have. We're currently in the 6th wave of these cycles. You know, you start with water power, textiles, iron, moving to steam power, rail, steel. In 1900s, electricity, chemicals, combustion engine. In the 50s, petrochemicals, electronics, aviation. I think we all benefit from these innovations. And I think that we are also very familiar with networks, software, new media. These are tools that I'm constantly using in my work. And then all the way to the current wave, which is robots, Internet of Things, and AI. And I want to focus a little bit on, particularly on robots and AI, the next projects I'm showing, because I'm really using those technologies to kind of enhance the work, both conceptually, but also when it comes to actually delivering them and fabricating them at the end. So I want to start with this. This is, you know, this was an attempt to kind of look into AI as a tool where we can maybe create or use it for automation, for optimization, to kind of create maybe conceptual art that we have potentially had to do by hand. So, you know, for a long time, I had been trying to create a certain kind of form language. So on the right side, you see what I consider a form language. On the left side, you see maybe a paradigm of modernism or the ghosts of modernism, which is just very basic geometries and form. So my interest here was really to kind of push these to create a series of form studies that I've done over the last maybe decade plus. So these are all drawings, basically pen on paper. You see here maybe a bit of a size and scale of how large they are, and there are quite a lot. I have really hundreds of them. Yeah, really trying to kind of see what I can achieve with that kind of form study. Again, these are very abstract. They don't have any size scale to them really, or any kind of presentation of performance. These are just abstract shapes. And because I have so many, I figured maybe it would make sense to load them into an AI model, which I've done. And this is actually a couple of years old. So now, of course, these tools are much more sophisticated. But if you look at this slide here, so if you go into the middle, everything on the left side is drawn by hand, and everything on the right side is drawn by AI, right? Which is interesting because I wouldn't be able to tell the difference myself, even though I've done these drawings myself. And that's when, you know, a couple of years ago, I realized maybe I don't have to draw anymore. You know, so it's an interesting polemic that we're in. I still have to put my head around how to use this for our benefit, but I'm using it right now to basically conceptualize work and really use it as a tool and try to see what it can produce. Again, here on the left side, you have an analog drawing. On the right side, you have a digital drawing that constantly change and produces thousands and thousands of variations of the original. So what I was thinking initially, which is this kind of shift in paradigm from modern to something that I was interested in, now turns into this totally different environment where I have so much more control and opportunities what I can do, and I still would like to explore these more. But just as a kind of example, like this is a project I modeled in 3D. Quite, you know, takes time. Again, these are things where you have to consider structure, how it lands, material, form, and these things, and it takes, you know, quite a bit of understanding of the tools and the trade. But now within seconds, you can do this in Mid-Journey. You can create variations after variations, which of course are still something you have to translate into reality, but it just gives me an advantage, or let's say a competitive advantage to save time, energy, and efficiency. So something that would take forever here, you can now actually start to create in a very rapid form. And we've taken advantage of this in a couple of projects in the last year. So this is a plate structure that I designed that was fabricated in Indianapolis. This is a fiberglass piece. It's going into a school in Washington, D.C. And you see here the kid is climbing, playing around. That's exactly what we wanted it to do. Again, we had a head start because we used AI to kind of come up with the initial form and then start to evaluate and optimize. And you see the form here installed on the right side on the playground in DC. Another project is in Taiwan. This is actually not something you can occupy. It's actually hanging in an atrium. But again, we use the same concept. We create some AI ideas and then start to really translate it into 3D, bringing the performance aspect into it, and materiality, size, dimension, weight, and these things. I don't have any further pictures yet, except these that I was sent. But I think the interest here again is the reduction of time to kind of come from initial concept to all the way to the fabrication of the piece. And then something that's getting installed actually tomorrow again in DC. This is an art piece that was again conceived in the same way. Again, this then translated into 3D. These are some of the details before it got covered with fiberglass. This is the project now before it was painted. So this is the pre-coating. And again, it's getting installed right now tomorrow in DC. And again, it's in front of a school. So this is for the public to engage with. You can sit in this piece. You can, I don't know, run around, take pictures, put it on Instagram. But this is the kind of work that I'm interested in, where we have the chance to create opportunities to people engage with the projects and maybe find some sort of meaning in them that is important for them. I mentioned robots earlier as one of those cycles that we're in, the 6th innovation cycle. And this is a project I'm showing here. Yeah, it was basically using robots, 6-axis robots, to print. So the entire project was 3D printed with a company called Branch Technology based in Tennessee, and they're using a material that allows them to actually print in space. So this is what they call the matrix. So you don't have to just do layers, but you can actually move in space. Here's a quick video of how some of these components are printed. The material is super strong, at the same time lightweight, so it's a carbon ABS mix. And then these things can be painted, or you can go in there with post production at the end as well. You see these robots. I think you have some of these robots on your campus as well. And they have quite a large facility. So I think there's like 6-7 robots printing these at the same time. So the amount of volume they can produce is quite high these days. So these things they don't just land in the world. This is in front of a library. And before the project, was kind of conceptualized, I went there, I visited, I had lots of meetings with the community, and we did a survey with the library. And we asked them, hey, what are you interested in terms of arts? Is it abstract? Is it more figural? Everyone was interested in abstract arts. We asked them, hey, what are your favorite books, authors, and so on, because it's a library. And there was actually 2 books that stand out. One is a children's book called Harold and the Purple Crayon, where basically Harold is a little child and he has a crayon that's magical and he just draws things. I think you can see the relationship here. And the other book was The Color Purple by Alice Walker, which is a novel about a lifelong struggles of an African American woman living in the South in the like 1900s. So these are some of the kind of things that we use to kind of charge again the work to kind of create, the figuration, the color, but also maybe a little bit the form and shape of these things, while also using again technology to produce it. I like to show also back of house pictures of how these things are put together, not just the kind of glossy images that we get from our amazing photographers. So the way this is done, you basically print this, you then put it onto a green screen and you scan it and you make sure it actually overlaps with the 3D model, right? So because the physical piece might be slightly different than the digital piece. So they have a very good system to make sure that each piece is almost like to the millimeter correct. And then, the interesting part, at least in my opinion, is that this is again using robots and the latest high-tech material, but the way it's put together is with zip ties. Right, so a couple of cents zip tie that you can buy in a store, and that seems to be the most efficient structural solution to actually put these components together. The components are based on size and dimension that the robot can reach and print, and then also in terms of handling. So this is one of the biggest pieces on the top left. We call this the baby elephant, and then the bottom left corner we call it the rhino. These are some of the pieces when they get assembled. And then you have the chance to put this together. I'm super fortunate that the client was up for this because it has never been done before. So you really need to have someone that's willing to take that journey with you and take that risk. But we're quite grateful that they saw the opportunity to do something that is really pushing technology to its limits. Again, it has to do with the context. This is library. This is actually a STEM library, so they're interested in science, technology, engineering, math. So these are things that are quite important for them as a client. And then we had the chance to do another project. Again, you see here, it doesn't even take that much to put this together. It's just a couple of people carrying these. They're not very heavy. And again, you just have to be very good in zip tying. And then there's just things that happen. We found this, like someone sent me this link to a video on YouTube. This was just installed, and then we found this thing. Just a second.
Sculpture is a mystery. It recently appeared outside a lab building in Cambridge, Massachusetts. There's no information plaque of any kind, no artist's name, no art title. But we do know a few things. It's clearly 3D printed, probably by a giant robotic printer from a three-dimensional digital file. And the dozens of 3D printed sections are held together by zip ties? Can you see them? So it was 3D printed in sections and then zip tied together on the spot. Ingenious. That's why it went up so fast. Oh yeah, a very similar sculpture recently appeared in North Carolina. Are they related? And who's that shadowy ghost running by? Stay tuned.
Yeah, YouTube. Sounds like Tom Maine, by the way, that voice. I don't know. Maybe. Who knows? But yeah, and then this piece is up now. It's in Cambridge, right next to the waterfront. And here just some images of the piece. With these kind of things, because it's still not very affordable to 3D print, you have to be very careful with mass and volume and these things. So, we had to run a couple of algorithms to make sure that we stay within that range that we can afford. At the same time, trying to get as high as possible, as much volume as possible. So you see here a few things, and there's, you see the final design, but there's many iterations that we had to go through to actually get to this point to deliver this piece. Another project called Figure. This is a bench, and this is something that, again, very early when I had the chance to do a few things. This is a commission I got for Art Basel in Miami. And here the idea was really to kind of challenge the paradigm of what a bench is, right? Like, how do we look at this? It's not a linear piece where you sit and look in one direction, and you sit next to each other, but you never talk to each other. The idea here was to really, like, curve the piece, and actually you have the chance to look at each other, or you're forced to look at each other and start to engage with each other. And that's maybe is what I'm particularly interested in with my work. It's like creating these opportunities where people can start to interact and communicate. So when I talk about production of culture, this is just part of this kind of idea. This is a bench that we would have loved to make it with like fiberglass or something super glossy and super finishes, but we couldn't afford it. So this is actually sectioned, and it's sectioned with high density polyethylene, which is basically recycled plastic. So you probably have these things, using them as trash bags in your home. We're using them to make a bench out of it. There's many components for this piece, and this is just a drawing that shows the iterations. This is just CNC cut. I was fortunate that SIARC was so able to offer me their CNC machine in the summer when no one's using it. So we had the chance to use it, and you see here also, on the bottom right, the network of actually steel structure that's in there, because this is something that needs to be supported internally as well, with lots of rods and these things. So it took a lot of logistics to make this happen. But if you look at the final image, you don't see any of that evidence that's inside. So there's entire internal sites or organism that lives inside this bench that is just never visible to the naked eye. Another piece is a subdivision. This is also very early. This was in collaboration with Matthew Au. I think, Matthew, hey, how's it going? He's right here. This was a chance we had to do a project in Eugene at the University of Oregon. This is in their math departments, and we won this competition with this piece that's hanging in the atrium. And it was all about being lightweight, because we couldn't really afford to hang too much weight from the ceiling. There was quite a limit. So this is using super thin aluminum. The reason it's kind of has a curvature is to make it more structural. Also, we didn't really have the funds to afford any milling or like expensive 3D shapes. So this is actually put together out of flat cut material or sheet material. I was teaching at Georgia Tech at the time, and one of my colleagues in the math department there was Greg Turk. He kind of developed an algorithm to tessellate complex geometries to make them developable surfaces. So this is what we've done here, basically, to kind of create these stripes and then basically put them together with rivets the same way like an airplane is put together. And I'm showing this image on the left because sometimes it's not clear how large this piece is. When we do these professional photographers or have them take pictures, but you see here the size of the scale of this thing. And again, we could only hang about 180 pounds from the ceiling, and this is maybe just under 100 pounds, this entire piece. That's just how light weight it is. Again, I talked about the assembly process. So here you see all the components, and there were hundreds of them. We used, obviously a machine to cut them, but then we had this amazing old school kind of roller that basically would roll them into shape, and then have them put together with rivet guns. And what's interesting is that these rivets give it this additional texture. And you see here the holes that are in the piece. They were actually there for two reasons: one, to make it more lightweight, but also to give it a direction when you put it into the roller, so you actually know how to roll it in what direction. I talked about families of projects earlier. So the next one here is in a similar way. This is a project in Denver at the University of Colorado, inside one of their new academic buildings. This piece is a little larger, so it had much more pieces, but it's basically put together the same way. It's rationalized, it's tessellated, and then you have these elements that you can then put together. And because of the curvature, it creates its own structural strength. And then it's partly hanging from the ceiling, and partly it's attached to the wall. So it's kind of this hybrid structural system that we had. And of course, color is important to many people. I don't think this is the color we proposed, but the colors of UC Denver are white, black, and gold. So sometimes you have to go with what the client's asking. So, but it's fine. I like these colors, but I think we had like a pink tone or something initially that they didn't go for. And then another piece in that series, which are these kind of like hanging structures or hanging kind of UFOs almost. This is at Georgia Tech, where I used to teach. in their new academic building. Again, very similar way of constructing, very similar way of conceiving. This is inside this very large atrium. This was much more complex to build and also much more complex to install. And it was actually only supposed to be there for like a very short time, maybe like 6 months. It's been probably 8 years now, and it's still there. So maybe it's too difficult to take it down as well. I'm not sure. But it's interesting because it's really a 360 piece, so it's really visible not just from the ground, but also from all the floors. So it's something we had to keep in mind when we designed this, that it's actually quite visible from every single angle that you look at and how you can participate. And every time you turn a corner, you might see it again. And every time you're on a different level, you have a different view of this piece and really explore and get to know this piece in a totally different way and light as well. And the shadows are quite interesting in this space. I don't really have the pictures of it, but there's quite an interesting light play that happens, you know, with this piece and these cutouts that we introduced. So installing this was, again, as I mentioned, a bit tricky. This was a fairly new building, and the way it operates is that they have this massive atrium, and if there's a fire, you know, all the doors shut, and there's a massive kind of ceiling fan at the top, and it basically starts to suck out the smoke that might potentially be there. So we had to make sure that if that happens, that this piece wouldn't just take off because it's very lightweight. So we worked with a couple of engineers, put these balloons in there that says happy birthday. And then we measured, we ran basically the fan at night, and then we measured the uplift, and we figured out that it should be okay. But that was one of the things we had to do to make sure we actually can install this and get the green light also from the fire department at the end. And then, yeah, this is, again, back of house, or, you know, when you put things together, it's what it takes. I can only recommend to have a lot of area to stage when you do these things, because you need a lot of space to put these things together logistically. And then just, again, for scale reference, here's a few people on the ground putting this together, putting the final touches. We used a very thin aluminum this time, and ultimately we noticed it was probably too thin because it was starting to dent a little bit. So you see David there on the bottom with a hammer trying to get the dents out, because the material was just a little bit too thin at the end. And then a couple of years later, I get a phone call that, you know, they wanted to film a movie on campus, and they would be interested to have our piece in the movie, and I would be willing to have the piece in the movie, and they would pay me a bit of stipends, which I happily accepted. The movie is called Super Intelligence with Melissa McCarthy. I don't think it made the cinemas. I think it's just HBO. But this is the movie here.
Don't worry, girl. Right? This is what I do.
Okay, what do I do in the meantime?
Well, you just go home, okay?
I think it had like two appearances in the movie, but
Squeeze the care package. There we go.
I have to
Got you, all
admit
right?
I didn't watch the whole thing.
Okay. You know how to get out of here, right?
Yeah.
Let's follow that to
Yeah.
Okay, and then, yeah, I was just there in the summer and walked by and said, this is only supposed to be the 6 months, but 8 years later, it's still there. And this is the picture of it hanging just this summer. So it's still around. Okay, so next project, and sometimes these projects, they're built upon each other, right? Like they just get better. So you just learn something, you evolve, you learn something, you evolve. So there was a lot of things we learned from this project that we took into the next one, which is called Phantom. This is a pavilion in Denver, or actually between Denver and the airport. There's a new area called Stapleton, and this is in this peninsula. This is a water basin for flooding, and they wanted basically a pavilion on that kind of peninsula as a kind of focus point for the community. And again, this is a project that's there to kind of make sure we can offer spatial opportunities for people to come together informally or formally. I think there's the video here. And it's, again, using very similar techniques. It's using these stripes. This time it's a little bit different. We have an exterior skin and an interior skin. So they're kind of cross-laminated. So all the interior stripes are white and all the exterior stripes actually have color. And because of this dual combination, it creates a structural strength at the same time, also because of the curvature of the piece. It has this kind of strength to it. And then there's also openings, and you see here in the video these kind of light effects that it produces. It's almost like being in the disco with a disco ball. And these are things that you can't really, there we go, you can't really anticipate when you design it. It just happens, I think, in the aftermath, but it was quite interesting to see it in the video appear because we never really thought about this at all. The openings are there for a couple of reasons. A, to bring light in, to allow a bit of kind of illumination. But it was never anticipated to have this effect that it produces ultimately. We also had to take into consideration snow load. Denver gets tons of snow, so these are a couple of pictures we took with drones afterwards. And we have some more where really the snow piles up and it creates this like new domes on top of the existing domes. Yeah, so just a few pictures here of the piece in more detail. This is also in collaboration with Matthew AUD, and Austin Anderson was also part of it as well, and then David Moore and some other people. And again, it's these are projects that I don't do all by myself. That is impossible. It always takes an amazing team and partnership and collaborators and consultants. So these don't just happen by yourself at a desk. This is really a very collaborative effort, and it takes quite a lot of amazing folks to come together to deliver these at the end. So just some effects from the inside, the patterning, and I mentioned these openings that we have that creating this additional dimension of layers and shades and shadows and light effects. And maybe one thing to mention is that we wanted to make sure that these openings are not at the bottom, because that's where kids would get their fingers into potentially, and if they wanted to climb it. But the more you move up, the more the openings get larger, so you get a bit more light in there. And then just a few, again, back of house pictures. This was actually fabricated also in Denver with a company called Demiurge. And again, you see what it takes to kind of put these things together. It's just sourcing the material, cutting the material, bending, breaking the material, painting the material. Of course, a little cleaning involved at the same time. And then, yeah, you have thousands of pieces, and then there's someone with a laptop that says A goes to B and B goes to C and so on. It takes a bit of logistics to put this together, but again, having a great team makes all the difference at the end. So just a few more images of the details of this piece. Okay, so another project is called Cloudscape. This is one of my favorites because I had the chance to bring my daughter there, and she was just like, I don't want to leave. So that was really cool to have that experience. This is at an airport in Fort Lauderdale. This is really what they call an interactive lounge. So they want people to kind of have a space to kind of hang out, spend time when they may miss their flight or when they wait to their flight. And they wanted something that's airport themed. So I thought, okay, why not create an immersive blue space? So we created a blue ceiling, a blue rubber floor, and then these kind of cloud-like shapes. And basically have them start to kind of layer on each other. You see here very Werner Panton-like environments. The important part is also that this is technically a playground. So we had to also follow Parks and Recreation Officers guidelines, not having any sharp corners or anything where kids can get their fingers into or where heads can get stuck. I mean, there's a whole kind of manual of things that you can or cannot do on playgrounds, which is eye-opening. But it also helped shape the design a bit. Things got actually more abstract, more simpler. Really, we had to reduce the amount of detail and really bring it back to the basics. So you see the stations. Each station has a different way of engaging with it. And then some of the images that you get when you basically look from one end to the next. And then we asked a couple of kids to come in and pretend they're playing. So here you get some pictures of girls reading books or kids playing. Again, these are the photo shoots that are professional, and sometimes they look maybe too professional, I'm not sure, but I think the kid set's fun, so that's good. The other thing is also because this is an airport, the fire rating is one of the highest that you can imagine. So the materiality of this piece is super important, which really influences the way you build this, but also the way how much you can build. We had to use this a type of MDF that has the highest fire rating. That comes with a price point, so we could not really do as much as we wanted to because we had to really make sure we can afford the material. And so this is all laminated kind of timber. And then you see here some of the cuts, some of the details. The other things we had to take into account is access to the sites. It's an airport. Airports are big, but the door to this place was really just a double door that we have, like the one we have here. So it's not that large. And you see the size of the cloud. So we could not really build them as one piece. We had to bring them in smaller pieces. But you see here the massive puzzling that we had to go through to actually produce this piece. To reduce weight, but also to reduce material, time, and these things. So it is just in the shop trying to put this thing together, lots of logistics that it takes to do this. And you see here also the components, and then also how we start to kind of connect them to each other and how we actually also lock them to each other. So you see the before and then the after once it's painted. Also because it's used by kids, by people, by anyone really, it gets a lot of impact. So we had to make sure that the coating is very resistant and can take those impacts. So the durability is quite high, and the maintenance with any project in the public realm, the client wants it to be as low maintenance as possible. So that's something we had to do here. And I think it's been maybe 5 years, and we so far didn't have to go back to do any touch-ups. So that's a good sign, and hopefully we can continue that over the next couple of years at least. And yeah, just some images of the kids playing and wandering in those Pantone-like spaces and reading books and hopefully having fun. Another project, again, in the public realm, this one's called Islands. This is a piece in Boston, in East Boston at the harbor. These are 5 structures. They all have these kind of funny-looking fins or sails, and then they have these cutouts. The cutouts really are there to occupy, so you can actually like sit in them or stand in them. I think I have a video, and these things are on pivots, so they rotate around. So you can always put them in new configurations and start to really participate in this art piece. And you see they're painted white on one side and then colorful on the other side. So you can always rearrange them, reconnect them, and really start to kind of create your own kind of landscape or environment for this piece. It's easier said than done to rotate these things. We really had to like test how fast they rotate, because they can't rotate too fast because it could be too dangerous for the public. They can't be too slow. They need to be rotated by one hand. So there's these all things we had to measure and take into account when putting this together. But you see here the piece and then the city or the skyline of Boston in the background. And I don't know if you know, but East Boston was actually a series of islands in the past, and it used to be 5. So there's 5 pieces. They all represent the islands. They all have had names like Hawk and so on. And some of these are references to kind of landscape forms and then man-made forms and how they come together and create these kind of new shapes and forms in general. And then, yeah, just some pictures, framing the view potentially of the city in the background, and how people engage with these as well. These were a bit tougher to put together. I was thinking aluminum didn't work structurally. There's a lot of wind in Boston, especially at the harbor. If you have ever spent some time there, it's very windy. So we had to switch to steel. That opens another can of worms, which is really about the welding part and so on. increases cost. So these are things we had to take into account when we put this together. Also, the painting, it's, once they were welded and produced, we actually then had to paint them, but they didn't really fit in the paint box. So we had to build a paint box around them. So some artificial environments to actually paint it. And then this is how we painted them in this position. That was just the most efficient way. Looks strange, but sometimes you have to do stuff upside down or sideways to make it happen. And when that was completed, we put them on a truck and basically start to kind of ship them over and install them. And yeah, I had asked some friends as well if they can stage some pictures. This is Max Guo and his daughter, who was so kind to come and be in those images as well. But I mean, again, these are stage pictures, but this is what we see when we go typically and spend some time there, like kids playing with their parents, or just, adults reading a book or just hanging out, and they really start to activate the plaza. And that was really what the client was interested in, that this thing is something that would start to populate the plaza and make people want to go there and spend time as well. So just some more images of this piece. Okay, so final project for this evening. This is called Drift. This is a bridge in Fort Worth, Texas. So we've seen, pavilions, benches. We've seen playgrounds. So these are all pieces, again, that are in the public realm that you can start to occupy, you can participate. The bridge, of course, has much more meaning sometimes, right? So it's connecting things A to B. This was important because you see here the north of the creek and the south of the creek. The creek itself was really cutting this neighborhood in half. The creek is there for rainwater or storm water management. And it was really like splitting the neighborhood in half for decades, right? So the people in the north had no way to go to the south and vice versa. So when they improved the sidewalks and the creek itself, the city put some money aside for art and said, okay, can someone please buy a bridge and put some art on top? Literally. And I said, well, how about we just design the bridge as an art piece? It's also infrastructure, of course. So that's what we tried doing. And I mentioned my daughter. This is when afterwards we went to visit her jumping on the bridge. So this bridge is made out of two materials. It's a steel frame and then clad with Spanish cedar, which is neither Spanish or from Spain nor cedar. But it's a very durable outdoor timber that is malleable, so you can really shape and form it, which we had to do here. And it's also very resistant to the climate in general. So this is a piece. So you see, again, it's not just a bridge for pedestrians and cyclists, but it also has these benches. They're kind of evolving from the form. So we start to kind of really shape it so that people can start sitting in these areas and, again, start to have maybe informal conversations, meeting some neighbors, and yeah, just getting to know each other. And the interesting part is that this is really happening. So a couple of years after, we talked to our commissioner, and they're getting so much feedback from the community how important this bridge is, because it really starts to make sure people that never met each other now have a chance to cross and actually get to meet each other. But also this connects a whole park system that the city has set up. So now if you're a cyclist, you can actually drive through several parks, cross the bridge, and continue on the other side on the other parks. So these are things that really are beneficial with a piece of infrastructure in place like this. However, we also wanted to make sure that this is not just something that is a typical bridge. We want to again challenge a little bit the status quo. The budget was very slim, so we could not build a scaffold and then build a bridge, which is how we typically build bridges. You build the bridge first, and you build a bridge on top of it, technically. Here we had to be a bit more imaginative, so we actually built this piece off-site, put it on a truck, and then drove it down to Texas and basically put it into place, which I call plug-and-play urbanism in a couple of references I've made. And I'll talk about this in a few seconds, but you see here cover images of the bridge itself, how, it's forming these benches that you can sit on, and then also some of the rails that are integrated. So for ADA purposes, there's a certain kind of slope you have to follow. There's a certain kind of handrail height you have to follow, and these things, they're all built into this form, basically. And a few kind of close-ups of this as well. And then back of house, we had to produce these kind of custom beams, which are kind of the center of the bridge. It's then really clad with these sections, pretty much how you build a boat or a ship. Each of them have a custom profile. You then start to build the first structure, the secondary structure, and so on, and you start adding to it as well. And this is also during the pandemic, when it was difficult to travel, and people were still cautious, and masks and everything, right? Of course. I, however, had the chance to go and visit, and when I saw the bridge, just in this state, I was actually quite intrigued. And I was a bit disappointed with it with timber, because I kind of like the structure itself. I mean, imagine it's being painted like in one color or in several colors. So I was like, oh man, I wish we would, maybe the next bridge. Okay, so timber, right? So Spanish cedar. So each piece is unique and is custom. Because of the curvature and the complexity of the shapes that we had to custom or flip mill each piece. So each timber piece is milled from both sides and then kind of like released and then basically kind of treated and so on. Sometimes because of the curvature, we had to also steam them, so to steam bend them as well to put them into shape. And then slowly we start to kind of clad this piece from the outside and from the inside. And then you can see here, this is just growing slowly. Again, during the pandemic, not everybody was able to work. So it was a bit slower than anticipated. But that was also okay, because it gave us time to really put maybe the precision in that it needed. Because again, each piece is individual and unique, and it takes just a bit of extra effort sometimes to do this. And then again, we had another visit. This is the client that came as well, standing there on the other side, looking at this piece. And then the piece was finished, and then we're like, okay, let's make sure we can also like deliver it now. So we used again AI a little bit. This is so the bridge is actually a 3D model that we basically put into augmented reality and projected it onto the truck bed to make sure it fits, right? So we actually had to make sure the dimensions are correct. And then we noticed a few things that are not working, had to then change some of the detail and some of the way we put it on there. But this was very helpful for us in terms of technology to make sure we actually have all the dimensions right and this can actually work. And then the big day, we were able to kind of take it out of the shop. And again, this thing was designed to fit a truck. So we had to scale it to that size. We had to make sure it comes out the gates okay. And literally we had like 2 inches on each side, and that's what we engineered it for, and it worked, luckily. Because imagine you built this bridge and you can never get it out of the shop. But it worked, and then we were basically cladding it with what you see very often at the East Coast when you look at yachts and boats in the winter. They get clad with this polyurethane. And then we drove it from Indianapolis all the way down to Texas. Took I think a day and a half, and then we stored it for like a week, and then we basically got rid of all the material, and then basically brought it to the site. We had announced this to the public, because we had to like block the streets a little bit for a couple of hours, but also because it was quite a spectacle for this thing to arrive, and everybody was quite happy and supportive. And you see maybe later in some of the videos and images, people standing there or with their picnic tables and looking and watching this thing being put in place. So here it arrives. Then it's on site. This is the bridge, just waiting there. We had an amazing rigging team, quite a big crane to pick this thing up. You can imagine it's quite heavy. And this is the diagram how I anticipated it from the very beginning to work, right? So a truck shows up, there's a crane, there's a creek. There was no water in, luckily, when we put it in there, but basically plug and play. So I was anticipating this to be like a couple of minutes. And this is basically what we aimed for. And that's how we basically delivered. We delivered this thing really in a couple of minutes to go from a truck into its position. The foundation was set before, of course. And when it was landed on its initial position, it only took a couple of people to just put the bolts in and screw it together, and it was done, right? So when I say plug and play urbanism, this is really maybe a good example of how you can really, with the least minimal amounts, have road closures, only a couple of hours, but also the way you look at the landscape. You don't want to damage the landscape or do too much to it where it's not needed. So yeah, just a couple of drone pictures. This thing being lifted into the air, and then positioned into its location. And I think this is one of the videos. We were quite fortunate that one of the folks in the shop had a cousin that had a rigging company in Texas, so that was a good connection. And then, of course, when you think about how to lift it, there's like lifting points that are engineered in. This is all like balanced accordingly, and you see just a couple of people with these ropes, just kind of making sure it just goes into the right direction. And then the foundation was already set, as you can see, and then all we had to do later is come in and just finish the pavement to the existing walkways. But the bridge itself was ready to go. Okay, and then yeah, just again a couple of final pictures in the landscape. This neighborhood is full of mid-century modern homes, so they were quite happy with the aesthetic of it because it's a bit of a reminiscence of like some of the Charles and Ray Eames work, like the leg splint, for example. So these are some of the references I showed when I initially showed this work to the clients and to the neighborhood as well. Yeah, and then just a few more pictures of this piece. And then yeah, formation powered by technology. I think I'm going to use this as a slogan, in the future. But again, I'm trying to use formation to really, create work that has impact in our culture, particularly when it comes to participation or creating spaces where people can participate or have an opportunity to participate. Because I do think that when we participate, we communicate. And when we communicate, we learn and we evolve as a society. Yeah, so that's basically hopefully the takeaway. But if there's nothing else to take away from this, then there's always AI at Midjourney, and maybe you leave it with a picture of Brad Pitt covered with a group of kittens. Right. All right. Thank you so much. Appreciate it. Yeah, sure. Yeah. Stealing the microphone from you. Oh, yeah. It's stealing.
Yeah, thanks so much. So nice to realize so many photographs. Any question about these kind of work from AI tools, right? And I How long the process. Just you talked really young and how that participated process. And I don't think that it will be benefit for you. It's kind of speeding up the process. This is the action. And I was reading a little bit about API, artificial general intelligence, so the capacity of artificial intelligence to now commission robots that will come with the assembly, so transcending the physical world. So I don't know if you have from the top of your head how long, for example, one of these to design versus how it's acceptable. I would be very curious. And the second is very mindful that using some of these technologies to participate in other parts of the process or just the
Yeah, no, a good question. I mean, typically the production process is the longest time, right? It takes the longest time. Well, or let's say the fabrication takes the longest time, right? And it really depends on how complex it is. I have noticed that most of the time, especially when I work with folks that I haven't worked with, like fabricators, it takes usually longer than they anticipate because there are just maybe additional steps that they haven't considered. So that body of work takes definitely the most amount of time and energy. It's interesting you mentioned the hand-drawn numbers, and Matt knows this very well. Like it's actually expensive to carve. I mean, you can also like laser cut the numbers, but it costs money, right? And also when you paint them, you don't see the numbers anymore, right? So you have to kind of find that analog way sometimes to trick the system a little bit as well. But those are things you learn along the way. I mean, you make your mistakes and then you evaluate and make it better. To be honest, now the biggest issues I have they're not necessarily issues, but is to follow not the fabrication process are things we have, I don't want to say figured out, but we have a good control over them. What's tricky now is like to put these things in the public realm and to deal with ADA requirements. Like the pavilion you might have seen, there are actually like concrete bars on the floor because you have head height issues, right? So you might actually hit your head when you're walking and you don't see these things. So those are things we now take into consideration that we didn't really consider before. Before it was all about how to make it more efficient, how to make it fabricating faster, but now it's totally other criteria that we have to deal with. But again, we're learning and things just get better and better typically. But then you do something totally new and then it creates a whole nother set. Like with 3D printed work, that's a whole nother set of problems that you're facing that you don't face with any type of metal work, for example.
Thank you both on this. It's really amazing to see them in totality, and I really kind of enjoyed this whole this series versus what do you call them?
Signature.
The signature. Yeah. Well, talking about that relationship, I think, especially looking at the process in which you engage machine learning in the ideation and also by the iteration processes. My question is like, how do you feel about the difference between communicating through language versus communicating through images? Because the older models that you have used were trained on your own drawings exclusively are communicating in the realm of images. But now the contemporary diffusion models that we all use are primarily focused on, like, describing through language and imagery, and then basically force feeding that algorithm that language so that you get what you want. And I think that's a completely different way of working that I struggle with myself in my own process. But it also, I think, aligns historically very divergent domains of visual communication versus linguistics, right? So I just wanted to hear your thoughts about how that transition, even though it's like so instantly important, it's also quite challenging because, you know, I'm not an author, you know, I don't, you know, English is my second language, but, you know, I just think that this kind of dependency on communication through language somehow also infiltrates the world of images, and I find that
Yeah, it's a good point. I mean, I was one of the very early Midjourney users, to be honest, and I was just fascinated. You know, I would just be there like on my phone, like generating image after image, and just like fascinated by the process. I wasn't the only one. There's many others, and you can see how they do it, and then you see what their prompts are. I did stop though for about a year using it after I worked or looked at Google Lens or used Google Lens to actually then reverse the images. Right? Like, let's say you put something in, it creates something quite spectacular, you think it's novel and unique, then you use Google Lens, which tells you where these images are actually coming from, right? The reverse engineering mechanism. Because everything the algorithm puts together, an algorithm can also decipher, which is, I think, quite amazing. So that kind of took away the magic for me a little bit in the beginning. Now, now these things are much more sophisticated, so I'm more interested again. But it's almost like, you know, especially in the architecture discipline, like we have spec writers, for example, right? It's like that's a discipline that didn't exist in the past. Like you would just like specify a product. Now it's very determined what it is, how to get it, and so on. So it's this additional set of information or code that you can add to some processes. And I feel like with languages it might be right now the same. It's just this additional set of information. Because if you put an image in and say now you can describe an image, right? It gives you 4 different options. But then you reverse it again to create the image with that code. It doesn't give you the same image. So I don't know yet if the wording is as sophisticated as the image making at the moment. It might take a bit of time to evolve, like it did with what I've experienced in the past with AI. But yeah, maybe in a year I can answer that question in more detail.
when you're working on that.
Yeah, there are a couple of projects that I'm doing. There's one in Denver, which is like interior, like inside a lobby. But the one I'm but it's very similar to what I've shown in terms of your work. But I'm still waiting. I would love to do another bridge. That would be awesome.
Thank you.
Yeah, it's a good point. I mean, some of the work is indoors, so there's no issue there. But we're building, or we're about to start building something hopefully soon here in Redondo Beach, right at the beach. And you know, you have to consider the climate, right? Which is corrosion, weather, salt, these things. So that influence the material choice, that influence also the painting and the coating for these things. So that's one. I was just asked to do something in Phoenix, Arizona, and I don't know if you've ever been in the summer, Phoenix, Arizona. It's an extreme climate, right? So you can't really produce or propose materials that you can't really use in the summer, that get overheated, that expands, where the lifespan is very long or very short. So those are things that you need to know before you start taking into consideration, and it helps make decisions as well.
as a fellow, service. I worked with very many artists over the juries speak to those standards along the way. And so,
Yeah, I remember, and it was sad because there was so much effort and you know, and everyone that worked on it was working so hard on it, and it fell apart. It fell apart because, if I remember correctly, the orientation of the grain was in the wrong direction. It was cut in the wrong direction, and then the strength was lessened. Right, I think that was the reason it fell apart. So it didn't have the structural capacity in the material anymore because of the orientation of the material. I'm sure that won't happen again because now that is known. But also, to be honest, like we had to use material that's alive, right? Like that was, I think it was also a type of wood grain that was used. I use bamboo and rattan. I will never use that material again. Like it was so difficult and so painful to kind of put that thing together, and also like work with material that is malleable. But yeah, I mean, mistakes happen. Like, you know, we had a structure collapse last year that was getting built. It collapsed halfway during the process because the engineer made a mistake, right? So he puts in some numbers that basically, you know, didn't work, right? And then it fell apart. Luckily, we have insurance, so that was able to cover everything. And now we're rebuilding it next summer or next spring. And these are just some of the risks you have to take, unfortunately. But you know, if you have again a good team, a good environment that you can work with, you make the right choices at the end. But mistakes happen all the time. This piece in Washington we're going to install tomorrow that I mentioned was supposed to be installed last week. The rods were too short, so we had to have 12-inch instead of 10-inch rods. So we had to wait a week because, you know, some material was ordered, unfortunately, the wrong way. So these things happen, and then you just have to adjust.
you spoke a lot about the materials station as well as the questions. And I wonder the degree to which the materials come out. It seemed from the because I worked with materials, you know, not as a way to realize the design intent of the project. And I wonder, does it go the other way around when you say I have this material and I'm looking to do something with it or push that material away one time that material?
Not in a kind of Fry Otto way, to be honest. That it's not. That's usually not the way I work. It's not the primary, you know, driver, the material. It's usually, I don't want to say it's an afterthought, but it doesn't come at the beginning, right? So it doesn't set up the matrix to continue to make decisions. It's rather built into the infrastructure that's up early on. But it is an important driver because it has to do again with some of the climatic you know, conditions that we're in, but also when it comes to the methods of make, how do we produce it, where is it produced, how do we source it, and also availability. Like there was a lack of material for a long time over the last 3 years. Prices went through the roof. Of course, it's all post-pandemic. So things you were producing maybe 4 or 5 years ago just pretty much doubled in price. So these are all conditions you have to take into account. But I think with the 3D printing, there is actually a chance to kind of maybe go that route. And there's a project I'm trying to kick off right now with Branch that's trying to go that way a little bit. But it's right now a bit more on a research type of project. So it's not something I would put into the public realm yet because I don't know if it works. But yeah, I don't know if that answers your question.
I'll get back a little bit and ask questions about Marianne referenced your work also includes architecture itself, evolution here, and also. And I think within each domain, there's 3 domains, not 2. So let's say choose satisfaction, objects, novelty objects. And sexually first. So I'm just curious, how do you assess novelty operating? You certainly. I feel like there's another.
Yeah, good question. I mean, I'm aware that the work has a bit of a kind of new futuristic aesthetic, for example, right? So these are things that I didn't invent. These have been around for decades, right? There's many amazing artists and designers who have produced work that is maybe is very similar in its you know, in its kind of appearance. But you know, I'm trying to see basically how I can start collapsing certain components, right? So can I collapse the geometry, or can I control the geometry to kind of empower something else, for example, right? So I think that's the interesting part for me, where I'm creating a bit of a system that is flexible enough to kind of then start to adjust. And it's not really about the aesthetics. Ultimately, it's more about having the control of that system and to make sure you can actually like position it where needed. And it can't do everything, of course, but is it flexible enough to kind of maybe engage in an environment that it could also adapt to a different set of rules, for example, right? So that's more my interest a little bit, and maybe that's where the novelty is potentially. It's not necessarily the aesthetic, sure. It's maybe potentially the process, I think.
It's an issue that's bugging me. But when I saw it hit me again. The school of thought says that architecture only comes from they know forms are new. And to a certain extent, that is undeniably true. You will rarely, especially within the last, say, 5 to 10 years, see something that we haven't seen in other environments, more formal or aesthetics. However, I find it not that I respect a lot of the voices that are kind of calling for this, but the idea that creativity is born entirely from the inside does not seem to be true in so many cases. And I don't know what the question is here. I just would like to know the title of your lecture would suggest you absolutely believe that it can come from the inside, we can, from the outside, we can create novelty, something new. The answer to the last question seemed to be it might be in the production rather than the image or the form of it. But what's bothering me about it is the idea of being a teacher, interested in the idea of teaching creativity and the idea that we can't think outside of what is. Yeah, apologies, there wasn't.
Yeah, I noticed. Look, but that's, I think the word pursuit is here maybe what's important, right? Like it's a journey. Doesn't mean we're going to find the pot of gold at the end. But I think it's up to us to try to pursue and to ask questions that are hard, but also to have discourse about it, right? I think that's probably what will push the discipline forward, to continue to have the discourse. I see industries where discourse doesn't happen, right? Certain larger companies that are very protective about the IP. And I see disciplines where it does happen, and I see them advancing much faster and much more rapidly, especially in architecture. And I would say architecture is probably 5, 6, 10 years ahead of other disciplines because we have the discourse, right? And I think maybe that is what's important. It's not necessarily knowing the answers, but just pursuing the quest to go somewhere, right? I think, I don't know if Eric Moss called it moving the center to expand the perimeter. So I don't know if he said that, but that was always interesting to me, right? To move the center so the perimeter gets bigger, so we have more opportunities to connect things that weren't able to be connected before, right? And I think that is probably a good way to kind of just develop and evolve.
Very pleasure.
Thank you. Thanks.